Hi, my name is dr. Ahmath. In this video lecture, we are going to discuss about points defined in polar coordinates. A coordinate system represents a point in a plane by ordered pair of numbers, which are called as coordinates of the points. So we usually use the Cartesian system of coordinates when we are going to define any point with the pair of numbers. So for example, in the Cartesian coordinates, we've got two axis lines, x-axis line and y-axis line. And if you're given some point with the coordinates, for example, 3 and 2, in order to draw that point, we have to go 3 units in the x direction and 2 units in the y direction. So that's going to be the point in the Cartesian system. So it appears defining the points in this Cartesian system. So let us write this Cartesian or rectangular coordinate system is not filled well when we are going to define curves which consist of some circles, some circular motion or circular curves. So therefore we have to introduce the polar coordinates which are better dealing with the circular curves or circular motions. So these polar coordinates are going to be defined with the two attributes as well, but they're going to have just one line, axis line. So it is going to have just the center of the axis. So as we would have here the origin, which is denoted as the O, and here is the same. So we've got the center or the origin, and we've just got the pole. So just the horizontal line in the direction to the right. So this is going to be called as the pole. And if we would like to define the point in the polar coordinates, it also comes with the two numbers, a pair of numbers, r and theta, where the theta is going to be at the angle between the line which connects the origin and this point and the pole. So this is going to be the theta. So is the angle between the line which connects O and this point. So let me denote this point as a P and the pole. And at the same time, the R is going to be the distance, or the module of the R is going to be the distance between the origin and the R. So what we are going to do today is how we can transfer the points from the Cartesian system, which will be given with the coordinates x and y, to the polar coordinates, with the two numbers r and theta, and how we can do this vice versa if you're given the point and the polar coordinates, how to draw this back into the Cartesian system. So we're going to do these two things. But before we start, let's do some examples of drawing the points in polar coordinates. Well, let's say we are given the point with the coordinates 1 and 5 pi over 4. Well, in order to draw this point again, so I'm going to draw the origin and the pole. So that's going to be the pole, and this is going to be the origin. And we have to draw, first of all, the angle, which is going to be equal to the 5 pi over 4. So I know that 5 pi over 4 is pi plus 5 pi over 4 can be written as the pi plus pi over 4. And we know that the pi is the half a circle, right? So this is going to be the pi, and we have to do 1/4. So it is going to be pi over 4, and 1 is going to be the point which is far away from the origin at the distance of 1. So this angle is going to be the pi, the small angle is going to be equal to the pi over 4. At the sum, it is going to be equal to the 5 pi over 4. This angle is going to be 5 pi over 4. And this point is going to have the coordinates 1 and 5 pi over 4 in the polar coordinate system. So let's do one more example. So another example. So now let's say we are given another point with the coordinates 2 and 3 pi. So again, in order to sketch this point, I'm going to draw the pole and the origin, and we have to rotate this pole in the counterclockwise direction, direction for the positive angles. So one time revolution of pole around the origin is going to be equal to the 2 pi. But we have to still draw a point with the angle 3 pi. It means that we have to do half a circle here. That's going to be the pi, and altogether with the one time revolution and this pi, it's going to be equal to the 3 pi. So essentially our point is going to be here, which is at the distance of 2 from the origin, and the angle is going to be equal to the 3 pi, because the 3 pi can be obtained at one time revolving the pole around the origin in half time, plus the half time. So that's going to be our point again in the polar coordinates. So let's do one more exercise. So now let's say we are given the point with the negative value. So it might be, for example, 2 and minus pi over 3. So pi over 3, by the way, it's like 60 degrees, right? So pi over 3 is equivalent to the 60 degrees. So what I have to do is, so I need to draw a pole again and the origin. So we have to rotate this pole in the counterclockwise direction. Counterclockwise. For positive angles. But if you've got the negative angle, as in our case, we have to rotate the pole in the clockwise direction. In the clockwise direction. So this is how we draw the angles. So please note that this angle would be pi over 2, or 90 degrees, and this angle would be pi over 4, which is 45 degrees, or minus 45 degrees, sorry. And pi over 3 is going to be somewhere in between there, more or less. So that's going to be the pi over 3 with a negative value. So this is going to be minus pi over 3, because we are rotating the pole in the counterclockwise direction. So let me draw everything with a different color, so in order to denote this line. So this angle is going to be equal to the minus pi over 3. In contrast, this angle, for example, which is going to be similar to this one, it's going to be plus pi over 3, because we are moving the pole in the counterclockwise direction. So now we need to measure the distance between this point and the origin to be equal to the 2, and that point is going to have the coordinates 2 and minus pi over 3. Well, let's do one more exercise. So we have to draw the point with the coordinates minus 3 and 3 pi over 4. So well, previously we used to have always this r to be positive in previous examples. It appears that it's possible that r can be negative, but in this case, so I'm just going to draw the pole again. And if you remember, so if you've got some point here with the coordinates r and theta, the point with the negative r is going to be in the opposite side to the origin. So it is going to be alongside the same line, but it is going to be an opposite quarter. So if this point r and theta is in the first quarter, and this point with the coordinates minus r and theta is going to be in the third quarter. So please note that this point with the coordinates minus r and theta is going to be equivalent to the r and theta plus pi, right? Because this angle is equivalent to the pi, and this angle actually is theta, and the minus r and theta is equivalent to the r and theta plus pi. So we can draw this point here in two different ways. So either we can draw the point with the coordinates 3 and 3 pi over 4, and then just find the one which is in the opposite quarter, or we can draw the point with the coordinates 3 and 3 pi plus pi, 3 pi over 4 plus pi. So let's do the first way. So I'm going to draw the point minus 3 pi over 4. We have to first of all draw the point which is with the coordinates 3 and 3 pi over 4. I'm going to sketch the pole again, so that's going to be our pole. This is the origin, and 3 pi over 4 can be written slightly different way. For example, I can write this as a pi minus pi over 4, right? If I give the common denominator, it's going to be exactly pi over 4. So it means that, so this is going to be the pi, right? And this is smaller than the pi for exactly pi over 4 angles. So I'm going to draw this point. So this point is going to be equal to the 3 and 3 pi over 4. And if you remember, the point with the negative r is going to be in the opposite direction. It is going to be somewhere here in the opposite direction with the same distance from the origin. So that point is going to be minus 3 and 3 pi over 4. So please note that your points can be written with the minus r and theta or r and theta. So it appears in general the absolute value of the r is the distance between the point and the origin. So it is superbly important for us to know how to find the correspondence, how to transfer the points from the Cartesian to the polars and vice versa to find the connection between the points. So let's figure out how we can do this from the Cartesian to the polar. Well, if you remember, one point can be defined in both of the coordinates, and we have to just find its corresponding coordinates in the polar if you're given the point in the Cartesian system. So let's say you're given the point with the coordinates x and y. And if you remember, x and y means that this distance here is going to be equal to the x, and this distance here is going to be equal to the y. Well, at the same time, I know that r is going to be equal to this line, right? Or the distance or the length of this line is going to be equal to the r, and the angle is going to be equal to the theta. So by just using the trigonometric ratios, we can probably find the r and theta. So that's what we have to do. So if you're given x and y, how to find r and theta? So, well, I know that cosine of the theta is equal to the adjacent side x divided to the r. Well, at the same time, we know, so we have to do this in the vice versa. If you're given the polar coordinates, how to find the Cartesian, so we're going to do the similar thing and then vice versa. So cosine of theta is equal to the x divided to the r, and sine of theta is going to be equal to the y divided to the r. So from here we can find that x is equal to r times cosine of theta, and y is equal to the r times sine of theta is going to give you the coordinates of the point in the Cartesian system if you're given the coordinates of the same point in the polar coordinates. So let's do an example. So let's say you're given a point. Example. So let's say you're given a point with the coordinates 2 and pi over 3 in polar coordinates. Find the coordinates of the same point in Cartesian. So what are the x and y's? So I'm just going to use the formula which we have derived so far. X is equal to the r times cosine of the theta. So the r is equal to the t here. Cosine of the theta, cosine of pi over 3 is equal to the 1 over t. It's going to be t times the 1 over t, which is simply 1. Well, at the same time, y coordinate is going to be equal to the r times the sine of theta. That's equal to the t times the sine of pi over 3. And we know that the sine of pi over 3 is equal to the square root of 3 over 2. That's going to be equal to the square root of 3 simply. So therefore, the same point is going to have the coordinates 1 and square root of 3 in Cartesian system. Well, at the same time, we should be able to get the r and theta if you know x and y. So if you're given, for example, if you would be given this coordinates, how you would find the coordinates of the same point in the polar coordinates, 2 and pi over 3. So, well, I'm going to write down again the correspondence between the coordinates, so Cartesian coordinates and the polar coordinates. X is equal to the r times the cosine of theta, and y is equal to the r times the sine of theta. Well, at the same time, it is clear for me that if I find x in the square plus y in the square, that's going to be equal to the r in the square. So it's clear to see this from if I just substitute this. So if I substitute x to be equal to the r in the square times the cosine in the square of theta, plus if I substitute the same for the y, so r squared times the sine square of theta, that's going to be equal to r squared. Because if I take out the r squared from the brackets, it's going to be cosine squared and sine squared of theta. That's going to be equal to 1. Well, at the same time, if I divide y to the x, right? So let's divide y, which is r times the sine of theta, divided to the r times the cosine of the theta. It's going to be exactly equal to the tangent of the theta. Well, it appears if you are given x and y, so given x and y, then we can find the r from this equation, because r squared is going to be equal to the x in the square plus y in the square. And at the same time, the tangent of the theta is going to be equal to the y divided to the x. So that's going to be another example of finding the coordinates of the same point in the polar coordinates if you're given the one in the rectangular. So let's do a small example as well. So let's say we are given point 1 and minus 1. It is super clear for us how to draw that point. And what we have to do is actually we can find r. So x is equal to the 1 and y is equal to the minus 1, and I have to substitute them to this equation. R in the square is going to be equal to the 1 in the square plus minus 1 in the square. That's going to be equal to the 2. So that is why r is going to be equal to the square root of 2. At the same time, the tangent of the theta is going to be equal to y divided to the x. It is minus 1 divided to the 1. It's going to be minus 1. So it means that theta is either going to be minus pi over 4 or pi over 4 plus pi, right? Pi over 4 plus pi, or 2 pi minus pi. Anyway, so let's check whether the tangent of the minus pi over 4 is going to be equal to the minus 1. So I have to substitute this to the definition of the tangent. It is sine of minus pi over 4 and cosine of minus pi over 4. So we know that sine is minus pi over 4 is going to be square root of 2 over 2 with the negative sign. And for the cosine, it's going to be positive, because cosine of minus x is equal to the cosine of x. So it's going to be square root of 2 over 2, and that's going to be equal to the minus 1. So well, our point in the rectangular coordinates, if you would draw this, would be here, was the coordinates minus 1 and 1. And the same point in the polar coordinates, so if this would be the pole, so it is going to be in the direction of the minus pi over 4 angle. right? So this angle is equal to minus pi over 4, and the distance is going to be equal to the square root of 2, and that's going to be this point, was the coordinates minus 1, and sorry, it's going to be 1 and minus, sorry, it's going to be square root of 2 and minus pi over 4. Well, so we've defined the same point in two coordinates, in the rectangular coordinates and in the polar coordinates. So we've learned about how we can transfer the same coordinates into one or another coordinates. So in our next video lectures, we're going to discuss how we can sketch the curves in polar coordinates and why actually it is easier for us to do this in the polar coordinates. Thank you very much. I hope that this was helpful for you.